Who should sponsor my YouTube videos?
Khan
No, Khan Academy has their own videos. Why would they want to sponsor mine? Kroger. This math video bought to you. Well, if we were talking about like percent discounts or unit prices, or Kroger might make sense. Hey, Kroger, you want to sponsor my math videos?
Wait, honey makes sense.
Honey for the discounts?
Yeah, Mr. Vincent.
No, I will say, I don't know if I have enough subscribers for them to want to sponsor
I'll
me.
spam in the comments like the Kroger
I have my comments turned off.
Kroger.
It's dangerous for a teacher to leave comments turned on.
It might not have enough students.
1,000.
We have
Oh, I've probably had that account going. I mean, you could go back and see what my oldest video is, but for like 6, 7 years. Really? I mean, okay, so I wasn't recording my classes like this back then, with like picture-in-picture and an HD mic and all that stuff, which I forgot to check what mic I'm on. But, getting back on topic, look at 726. I'm going to use some of Lane's paper because, well, I don't want to do all of the work on my own. And Lane's already done half of it for me. Haha, if you're trying to ignore me and just keep doing your Desmos, you're paused now. Alright, step 1 with a problem dealing with median, which is the middle, is we got to put them in order before we can figure out the middle. So Lane started by putting these in order, but the thing you want to double check, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. You let me go that long.
Let's go.
But if you go watch the YouTube video, my YouTube would have shown what I was doing the whole time. So 26, there are 14 numbers. So double check that we wrote down 14 numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. We forgot one of our numbers. And that's one of the biggest trap doors. So first things first, we've got to make sure we have every single number down here. I'm going to do a second cross for all the numbers we got. -5, -4, -3, -2. Can anyone just tell me what number I missed if you already have them listed? Oh, there's a +4 that we missed. So we forgot a +4, which is going to change everything else that we did, actually. What does median mean? And I already said this. The middle. With 14 numbers, which number, like the 5th number, 6th number, 7th number, which number would be the dead middle of 14 numbers? There isn't one. Donna, you got something to say? Yeah, because we have 14 total numbers. Guys, imagine this. You have 14 numbers in a string, right? 14. If I split that in half, I'd have 7 and 7, leaving no number in the middle. Right now, I don't know what you're doing, but I've got the Desmos paused. So, with 14 numbers, I need to count 7. 1, 2, 3, 4, 5, 6, 7. And then count 7 in from the other side. 1, 2, 3, 4, 5, 6, 7. My quote-unquote median number is between the 7 in and the 7 in. So what number is between 1 and 2? 1.5. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So your first median, which is actually your quartile 2, is 1.5. Questions on how we found that first median, which is really quartile 2. Right, 3 7s, I think, yeah. So now, quartile 1. Sorry, I need to look up, I guess. Sophie. Absolutely. The technical way to do this is add those two numbers together, Divide that by 2 because we're doing the average. So you're absolutely right. So now I have 7 numbers in the bottom half, 7 numbers in the top half. Quartile 1 will be right in the middle of these 7. And quartile 3, Lane, I hope you're paying attention since I'm doing this on your paper. Lane's like, I got this one for free just by asking. Which number, like first, second, third, fourth, fifth, sixth, which number would be the middle of 7? Lane? You're right. The fourth one, because if I cut 3 off of one side and 3 off the other side, it leaves me with 1 number in the middle, right? So if you cut 3 off and cut 3 off, the quartile 1 is -2. Quartile 3, I got to cut 3 off, cut 3 off. Quartile 3 is 5. And then the interquartile range, that if you go check your math notes that you just got yesterday, but I believe it's in there, it's the difference between your quartiles. Inter means between, right? We learned that. Range is like how far. Right, so inter, you learned that from stems when we did that. Inter means between. So interquartile range from -2 to +5. How far is it? 7. It's just 7, right? Because it's got to be positive, because how far distance has to be positive. Questions about 26? Any other questions about 712? And not you didn't do it yet, but you tried it and you didn't understand it. 24, nice glance right here, that as soon as you know 28 students are 40%, we can work it from there, and there's a few different ways to work it from there. All right, I will unpause your Desmo so we can play with those percent machines. All right, I know some of us, about 8 of us, are still typing our answer on this one. But let's talk about this real quick before we move on to the double machine. So we're going to increase by 50%. Well, we'll take that one. Sam, if we have 10 as our starting number and we're going to increase by 50%, how can we figure out what number we're going to get?
So I'm pretty sure you have to find out what 100% is first, right?
I don't know if we have to find, say more.
Oh, you mean 100% is 10?
Yeah, what we have to start with, that's our 100%. So you're right that we need to think about it first, but I don't know that we need to do anything really.
So then it would increase by 5 because 50% is half of it.
So then we know what this machine's going to do for this input is increase it by 5, making our output 15. Now here's the problem. If we set up another machine after the 15 spits out, now going through this machine, what's your 100% now? So now this is our new 100%. So I will tell you guys on the next slide where it asks you if you think it's going to be bigger, equal, or smaller. You are completely split. The votes so far are completely split, like almost perfectly. Let me anonymize real quick. So we are in a complete disagreement. If I was you, would make up an input to test out. Like, you could use the 10 that we were just talking about. So imagine you increased by 50%, got to 15. Now the second machine they set up.
Eli Brown, please come to the Perry office. Eli, please come to the Perry office.
The second machine they set up is going to decrease by 50%. So the next slide is asking you, do you think the result will now be bigger or smaller than the original? That original input. Do you think it'll be bigger or smaller than your original input? All right, keep working for a few more minutes. I don't want to stop you, probably at least for however long it takes for a song to play. It's kind of how sometimes I keep myself honest, letting you work. Sorry, who are we looking for? He's across the hall from me. What do we need?
We had a message that Mom cannot find his saxophone.
I'll go let him know and see if it's been located around here. does not matter if the answer that you had submitted is right or wrong. However, it does matter if you understand after we do this activity. So let's talk real quick with an example. Bethany, let's change numbers just for fun because why use the same number again? Can you give me like a nice number that we could increase by 50%? And then if you want to think about step 2, that then also that new number can decrease by 50%. Not like nicely. Honestly, this was going to become partial, like a half number. I love that. Can you think of an input that like at least we can increase by 50% like kind of easily? Yeah, 18 could be nice. I'm going to go even nicer and do 20, I think. Because I feel like 20 is a bit easier to work with. 18 would be nice. Pretty much any even number, right, would be nice to work with. So what if we start with 20? What's our 50% increase? 10, so we're going to go up by 10 for that 50%. What comes out? 30. This is the new 100%. So now when we decrease by 50%, what decrease is going to happen? 15. Because 15 is 50% of the new total. So what do we get out? 15. Are we more, less, or equal to the original? Less. Here's my worry. Like 6 of you, and I mean, things have probably changed now, marked that it would be equal when we talked about this yesterday. A percent change up, if you turn around and do the same thing down, you do not land where you started. A percent change up, turn around, do the same thing down, you don't get the same thing out. We went 50 up, 50 down, we didn't get back to the start. Sophie? Yeah. Yeah. Mm-hmm.
Right? And then you walk 50% of the way back.
Okay, so you walk 50% of the way forward.
And then you walk 50% of that way back.
Now we walk 50% of the back. Yeah,
It wouldn't work.
you're right.
When I said
Because then if I turn around and go 50% forward again, well, now my 50% forward lands me like here? Like, where you start determines everything, right? Yeah, what your hole is, which really, the where we start in this situation, how much sidewalk is in front of you, right? And that's like the hole. Yeah, you're right. All right, it's on pause. Keep going, guys. It's okay if you misunderstood this in the Desmos, but what matters is like when you get asked to do this on a worksheet or on a mastery, does it make sense then? Yeah. What percent increase? I think you're thinking the new number is 120% of the old. So you need to take the 100 off because we already have the 100 if they're only asking about the increase. Because you're increasing by the percent, you add that percent to it,
Oh, thank you.
right? You're starting with what you have, you add the change to it. Guys, I will be here early tomorrow morning also. If anyone wants to get as caught up as possible before we head into break. I'll just be like honest with you guys. I'm skipping game night tonight to get our tests done grading so I can get them back to you tomorrow. What would I prefer to do? Go to game night. But what am I going to make myself do? Get my work done before break so you can have it back, but also so I have less to do over break. I'll play games over break. Tonight, I'm going to make myself work. Sometimes you got to make those tough decisions. Like, I'm not making this up for real. I just got off the phone with my wife, and I was telling her, hey, I don't think I can go to game night tonight. You can go without me. So think of it as if you had 8 pizzas that you were cutting into thirds. How many pieces do you have now? And you could just count all the pieces, but this is 8 pizzas cut into thirds. So like how many thirds do you have now? Or you could say if everyone is eating a third, how many people can eat?
Oh, that makes sense. Yes.
So, funny enough, we did this next problem that you see on Desmos together because we chose 20 as our nicer number to use. So then we end up here that I kind of want to pick on Sophia to talk about what mistake you had made, but like that, it's a really good thing to talk about. Sorry, I'm trying to find my music to pause it. Sophia, what percent did you think? And guys, please don't make me pause it. I want to leave you unpaused this time, but just let you look up here. What percent did you think about initially?
120.
120. Why?
Because I did the math on my graph paper, but I got the 1% is 60 because 60 was 100, and I couldn't find 72% without like getting down like 1 or something.
So what Sophia said was if 60 is our 100%, and she said, I did the math on my paper. Give me like 20 seconds. I'll try to keep this to 25 maybe. So if we set up the new number is 72, and how do we get here? We find a multiplication because you can divide backwards if you need to figure it out. We can multiply by 1.2, which gives us 120%. But the trick here is
the 120%, it's like that's like 60 plus the new thing, but you only need like the new thing because you already have your 100%.
we're only being asked about the new thing. So how much did they add or increase?
20.
20%, which all of the answers that I looked at so far, all of you had figured out the 20%. What if this is our 100%? What's 10%?
3. Wait, no.
If
6.
60 is a, how much is 10%? 6. How much did this go up by? 12. Oh, there's another way we could do it. If 6 is 10%, 12 is 20. All right, keep going. So apparently Kay did something wrong, or Kai, because they ask us what we would change. Oh, and they straight up tell us he made an error. If we go back to our previous screen, that most of us, I mean, there's a couple of us still on it, but if we look at this problem of we got 36 out after increasing by 20, what was the increase? Guys, this is when this is like proud parent moment or proud math teacher, when I'm looking through and pretty much all the answers are agreeing. If we put 30 into this machine, we increase it by 20%, we would get 36 out. So what that tells us when we come over here to K's, the 36 we got out, the 120% out, what should we have put in? No, that's what Kai put here on the table. That's not right. We figured out on this screen what we should have put in. We should have put in 30. So Kai's got a mistake right here. This should actually be 30. How can we fix that? I don't know if changing it to 80% would actually fix this. 30. I mean, let's try this. 36 times 0.8. If you got a calculator, try it out. No, that 0.8 gets what Kai got. I think using the 0.8 is messing with Kai. So let's see. Something Kai did well times 0.12 does equal 120. Times the same on top and bottom. You should multiply the same on top and bottom. He should swap the last input and put 30 in as the input. Yeah, that's what we figured out, right? Is that the input should have been 30. But I think also, guys, I think two things are wrong, actually. I think this times 0.8 and this 28.8. Zane? What do you mean? So guys, I will tell you, and now I am going to pause. So there's your warning that you're about to lose control of it. If I can find it. Oh, I left it over there, that's why. I'll tell you what's right. If we take 100%, multiply by 1.2, do we get 120%?
Yes.
Yeah. Emery, stop doing your homework. So, this is right. The times 1.2, this is good. If we multiply by 1.2 going this way, forget about him wanting to multiply. What could we do the other direction?
Divide by 1 point.
Divide by that same number. Because if we multiply by 1.2 going this way, Matt, I don't know what you're doing, but your Chromebook should be paused right now.
Excuse this interruption.
We could do the opposite direction.
Could I have Hannah Schaefer to the office? The Perry office, please. Hannah Schaefer to the Perry office. Also, if you're in the building, could I see Elsa Hayes, Lakin Orr, and Keegan Hines in the Perry office? Thank you.
Because you might be tempted to do this sort of thing of like, oh, well, we went up by 20%. If we go down 20%, we lose and we're down to 80. We can't do the same percent, but we can reverse the process using the same number. Don't try to change and do like 20 the other way. But if you want to, instead of going right to left, if you want to go left, or instead of going left to right, if you want to go right to left, instead of multiplying, just switch it to division. Grab a calculator and do it on your computer. What's 36 divided by 1.2?
30.
It's 30, the number we wanted. You can spend the final 4 minutes working on homework or continuing the Desmos if you would like.